In section 7.4, we're learning about the concept of rational exponents. The word rational, you can just think of the word fraction. And so, putting it very simply, we're learning how to take exponents that are in fraction form, as is the case with our number 34, and think about these rational exponents in radical form so that we can simplify them. Simplify these expressions. So I want to give you some help. Again, please don't just rely on what I'm doing. Make sure that you can do these on your own. After you watch the video, then go back and see, okay, can I do this myself? And that's always very important that you're able to do this. All right, so for number 34, we have the number 32 being raised to the negative 4/5 power. So today we did a little review of the idea of negative exponents. And if you weren't in class today, we just said in Algebra 1, you learned that a negative exponent requires, here's a separate example, a negative exponent such as this requires that you write the reciprocal of what we call the base number. The base of this exponential expression is 2. So the negative exponent says, okay, well, what is the reciprocal of 2? And that would be 1/2. And then, after writing the reciprocal of the base, you can then change the exponent to positive. So 2 to the negative 2 is another way of saying 1/4. A couple more examples. The fraction, for example, 2/3 being raised to the negative 3. Well, as a positive exponent, and we always want to change negative exponents into positive, but that's going to require that I look at this base, in this case it's 2/3, and I write its reciprocal. So the reciprocal of 2/3 is 3/2. And after writing the reciprocal of the base, I can then change the exponent to positive. So 2/3 to the negative 3rd power, negative 3 power, is the same thing as 27, it's 3 cubed, over 8, it's 2 cubed. Okay, so just a quick review of negative exponents. I know you've seen them before, but some people forgot, and this is a trouble spot for some people in Algebra 1, so just thought I'd do a quick little review. So now back to our number 34. Along these same lines, I'm going to change this negative exponent into positive by writing the reciprocal of 32. That's 1/32. And then I can change this exponent into positive 4/5. Okay? And my directions are to simplify, and the way I simplify these rational exponents is I'm going to write them in radical form. So in radical form, this is going to be the 5th root of 32 to the 4th. Okay? So just a quick review of what we talked about in class. The denominator of our fraction in the exponent becomes the root of the radical. And then this numerator basically just stays with the base number, and it just is the exponent, all right, underneath the radical. So earlier in class I showed you without a calculator, because the test and the quizzes that we have for Chapter 7 are going to be no calculator. So I showed you an easy way to do the roots of these radicals that look like they represent large numbers, but actually these are pretty simple to do. Let's just think about this really in 2 parts. Let's think about what the 5th root of 32 is. Okay, the 5th root of 32 is 2. All right, 2 to the 5th power is 32. So now that we found the 5th root of 32, we just want to raise 2 to the 4th power, and that would be 16. So another way of thinking about these is like this. You can do the 5th root of 32, and then whatever that is, raise it to the 4th power. Okay, and for all of your larger numbers underneath radicals like this, that's a pretty simple way to come up with those, those roots, if you just think of it in two parts. So that's your answer for number 34, 1 over 16. Okay? Number 36 represents an exponent that's in decimal form. Well, immediately what has to happen is we need to change decimal form into fraction form. Okay, and 1.5, that's 1.5. In fraction form, that's 3 over 2. Now, you do want to leave it in improper fraction form because it's from this form that we convert into radical form. So the radical form of 16 to the 3/2 is the square root of 16 cubed. Okay, so just practice changing rational exponent into radical. Notice how this denominator basically becomes the index or the root. And once again, break this up into two parts. What is the square root of 16? The square root of 16 is 4. And then to get your answer, you're just going to do 4 to the 3rd power. So it's, again, I'll show it a different way. It's really like doing this. The square root of 16 first, and then whatever that is to this power. And 4 to the 3rd is 64. So that's your answer for number 36. Okay, moving right along. Number 38, this is a new section. Page 383, you're supposed to write in simplest form and assume all variables are positive. We reviewed our rules of exponents. When we have a power inside being raised to another power outside, then we multiply those two powers together. And if you multiply 2/3 times -3, you get -2. Okay? So basically this, in removing the parentheses, becomes x to the -2 power, and now we always just remember you never want to leave a final answer with a negative exponent. So changing this to a positive exponent means we're going to flip or write the reciprocal of x. The reciprocal of x is 1 over x, and then we can change the exponent to a positive. So your answer for number 38 is 1 over x squared. Okay, so here we have another example of an expression inside parentheses being raised to a power outside the parentheses. So everything inside the parentheses needs to be raised to this power. And there's really two different numbers being raised to the 1/3. So let's just show it as that. -27 raised to the 1/3 times. Now what do we do when we have a power raised to another power? We had an example of that earlier. We multiply these two powers together. So I'm going to have x to the -9 times 1/3 power, and that's -3. So I've removed the parentheses, and now I'm going to change rational exponents into radical form. So another way of saying -27 to the 1/3 is the cube root of -27. Okay, and I'm going to change negative exponents into positive. Well, that means I've got to write the reciprocal of this base number, and then I'm going to change, after that I can change -3 to +3. Okay, well, let's simplify these. The radical, the cube root of -27 is -3. Nothing to simplify here. It's just now a matter of multiplying these two together. And when I do, I get -3 over x to the 3rd. And that should be your answer for number 42. Okay, number 44. In this case, you notice in the parentheses that we're dividing, and not only dividing, but we're dividing by like bases. Both of these are base x. So what I would do here, there's more than one way to do most of these problems, but what I would do is use the rule of exponents that says division of like bases means you're subtracting exponents. So when you do 3 minus negative 1, that becomes 4. So instead of working with two different x terms being divided, let's just put them together as a single term, x to the 4th. And now, again, remember your exponent rule that says when one power inside is being raised to another power outside, you multiply those powers together. So 4 times negative 1/4 is negative 1. And now we always change negative exponents to positive, and that means write the reciprocal of our base, and the reciprocal of x is 1 over x. And then after writing the reciprocal, you can change the exponent to positive. And of course, I don't need x to the first. I mean, if you did, it would be okay, but your final answer for number 44 should just be 1 over x. Okay, I think I've got one more for you. This is number 48. The difference here is I'm dividing, but I'm not dividing like bases, so I can't subtract the exponents. So I'm going to remove the parentheses around this fraction by raising the powers inside to the power outside. And when that happens, one power raised to another, you multiply the powers together. Okay, so when you raise x to the 1/4 to the 12th, it becomes x to the 3rd. And when you raise y to the negative 3/4 to the 12th, it becomes y to the negative 9. Okay, and if you're not sure how I did that, let me just show you. Negative 3/4 times 12. You could have done negative 36/4, which is negative 9, or you could have done some cross canceling, and negative 3 times 3 is negative 9. Okay, well, we're almost done. It's just that, again, never leave an answer with a negative exponent. So you can think of this, if you just took this y to the negative 9, just think of it as 1 over y to the negative 9. And again, when you change negative exponents to positive, I guess I'll show it like this. That's okay. Flip this base, and the base is 1 over y, so that makes y over 1 to the positive 9. Or non-mathematically speaking, negative exponents on the bottom always move up to the top of a fraction as positive exponents, and vice versa. Negative exponents on the top of a fraction will move down to the bottom as a positive exponent. All right, so my final answer here is going to be x to the 3rd times y to the 9th. All right, so I think that's all the examples I have for you. I hope that's enough to help you with all the other ones. And again, if you had to rely a lot on this video, that's great, I'm glad, but don't let that be the end of it. Make sure that you can work these problems now on your own, now that you've seen how they work. And if you need further help, come and see me here in academic support.